In today's lesson, we are going to do a little quick trigonometry review. So we're not going to touch too much on trigonometry itself, but we're just going to look at some review of some facts about triangles, specifically angles, and a little bit of Pythagorean theorem, or sum of squares as it's now known, that may help us when we get into our trigonometry unit. So first of all, we have our opposite angle theorem. So this states that the opposite angles of two lines crossing are equal. So that means these two are the same and these two are the same because they're the opposite angles. Complementary angle theory means that these two angles, x and y, we could say here, x plus y have to form or add up to 90 degrees. Quick way you could figure that out. Complementary C, think of corner. Corner is 90 degrees. Supplementary angle theory. These two angles here, x and y, they form or they add up to 180 degrees. Supplementary, you could say, well, supplementary, think of straight. S straight line, 180 degrees. So let's solve for the unknown angles. So here we have an example, 2a for our one angle here, a, x, and y. Now we know what they all have to add up to. They all have to add up to 360. But I can't solve that equation because I have too many variables in play here. I have three different variables, so I can't solve the equation. What I hopefully see is that two sides, or that we have opposite angles in play. And two of those sides have the same variable. So I can use that to help me, the 2a and the a. I can use that to help me. So what do 2a and a have to add up to? Well, by looking at them, if I go and erase them individually, if I start on 1, form that angle, and come over to the other side, well, that forms a straight line, or 180 degrees. So 2a plus a has to equal 180. 2a plus a is 3a, so 3a equals 180. To solve for a, I divide both sides by 3. One side cancels out. I'm left with a is equal to 60. This will help me because I know then that this angle is 60 and the y is 60. What about the other one? Well, I could plug it back into the formula, right? 2a is now 2 times 60, which equals 120. Or I could understand that the two angles have to add to 180, so 180 minus 60 is 120. And then for x, the opposite angle theorem, so it's 120 as well. When looking at a sum of triangles, so looking at a sum of triangles, a plus b plus c, what do all the angles in a triangle have to add up to? They have to add up to 180 degrees. So let's use that to help solve for the unknown. We're going to do something very similar to what we previously did, because 3x plus 2x plus x has to add up to 180. I can add these terms because they are the same. So 3x plus 2x plus x gives me 6x equals 180. Very similar to the last example, divide both sides by 6. One side will cancel out. X equals 30. I can now use this. I know that this has to be 30 because it's just x. Here's 2x, so 2 times 30 equals 60. So this is 60 degrees. And 3x, or 3 times 30, which equals 90, is that unknown angle. So even though it doesn't have the square there, we want to be careful and make sure that we don't assume, right? Because algebraically it states that this angle is actually 90 degrees, right? So again, don't always trust the graph, or it's not the graph, don't always trust the diagram. It may not be to scale. Looking at some other triangles, right? Again, just looking at some definitions of some specific triangles. Equilateral triangle, all the sides are equal. We see that by the dashes, and all the angles are equal. All sides are equal. All angles are equal. For an isosceles triangle, 2 sides are the same, 2 angles are the same. Or 2 sides are equal. And 2 angles are equal. In a scalene triangle, no sides are equal and no angles are equal. Kind of following that same pattern. No sides. Oops. Or angles are equal. So here we're going to look at the side angle side, or angle and side relationships. So again, just one of the main things is that if this is kind of the point A, then side A is right across from it. Just kind of showing that connection. That's when we're labeling things, that's what we refer to. So we have C inside, angle C inside C. Oops, use a different color. Angle B and side B. So aside from those relationships, another thing we can look at, if I look at B, angle B is the smallest, so generally speaking, side B is the smallest. Angle C is in the middle in terms of size. So side C is in the middle. And lastly, angle A is the largest. So side A is the largest. Looking at this example here, what's wrong with this triangle? Well, let's take a look. We have the smallest side. Well, we'll keep it the same colors as the last one. So we have the smallest side. It is paired up, or the smallest angle, it is paired up with the smallest side. We have the largest angle. Ooh, it's not quite paired up with the largest side. So there's an issue there. All right, so chances are that there's something wrong with this side. Because we look here, the middle angle has the largest side. So chances are there's something off there with the numbers. You might also notice this dash is not the same as this one, so those two sides aren't the same, so there's an issue there. Another issue is that all the angles don't add up to 180. So it doesn't add to 180, right? Because 130 plus 40 plus 20 equals 190, which is bad. We don't want that. On this side, again, these two should probably switch, if anything. Looking at the transversal parallel line theorem, so again, this was kind of looking at, we've looked at this kind of in the past. So there are 3 letter patterns that we may come across. So those 3 letter patterns are the C pattern, and in this one, the 2 angles, I'll keep it consistent, D and F, D plus F equals 180. So that's what that pattern looks at, the C pattern. Another one is the Z pattern. So Z formed that way, or because we know Z looks more like this, that also works. Could be backwards as well. So we have C and F. In this case, angle C equals angle F. And then finally, we do have the F pattern. And the F pattern would state that in our example, D and H are equal. So it's just about looking at or recognizing some characteristics or patterns that we can kind of use to help us find other pieces of information. Lastly is the Pythagorean theorem. So in this again, Pythagorean theorem we might need to use, because what we can do is we can find missing side lengths, and when we get into trigonometry we will need to know side lengths. So this might be something that we use to find them. Key things: B and A are your legs. They can be interchangeable. C is your hypotenuse. And it's always across from the 90-degree angle. So if you're never sure, it should always be across from your 90-degree angle. So the Pythagorean theorem, again, we do now call it the sum of squares, because Pythagoras actually didn't invent it. It was invented before him. He just happened to be credited with it, even though he wasn't the one that invented it. And so the sum of squares, or what we know as the Pythagorean theorem, is a squared plus b squared equals c squared. So this is generally the formula that you use when you're looking for the hypotenuse. But if we're looking for a leg, it's probably better to use the other form, which would be, say, b squared equals c squared minus a squared. So looking for a leg. We'll correct our grammar, that's the top one. Looking for the hypotenuse. So again, that's just some terminology and some review of some kind of key terms and key patterns or rules that we may be using when we start to work with trigonometry. And again, most of that should be reviewed from grade 11 and even grade 10 when we get into it, so hopefully it's not too much of a shock.